You've probably heard that old saying, you are the company you keep, right? Well, it turns out that's not just some piece of life advice. It's actually the entire idea behind a machine learning algorithm that is, believe it or not, incredibly simple, but also incredibly powerful. Today, we're going to dive into how machines can learn to classify brand new things, basically by just looking at who their neighbors are. I mean, just think about it for a second. When you run into something totally new, let's say you meet someone for the first time at a party, how do you get a read on them? A lot of the time, you kind of look at the group they're hanging out with. Their neighbors, so to speak, give you a ton of clues. Okay, so let's set the scene. Imagine you've got two different groups of dots on a screen. On the left, a whole bunch of dots we'll call Class A, and on the right, another bunch we'll call Class B. Now, what if a new, single, mysterious dot just pops up somewhere in the middle? It doesn't belong to either group, yet. So, take a look. Where do you think it belongs? Your brain is probably already doing the work, isn't it? You're just naturally looking, judging the distance, trying to figure out which group is the better fit. You're basically asking, well, who's it closer to? And you know what? Your gut feeling is exactly right. The most obvious, logical thing to do is just see which group it's closer to. And here's the kicker. That super simple, very human way of thinking, that's the entire basis for a real-deal machine learning algorithm. All right, so let's give this idea its proper name. We're talking about the K Nearest Neighbors algorithm, or as everyone calls it, KNN. This is the moment we take that gut feeling, that idea of learning by association, and we turn it into an actual recipe a computer can follow. So the official definition is that KNN is a machine learning algorithm that figures out where new data points belong based on a similarity measure. In plain English, it just looks at all the data it already has, that's called the training set, and classifies a new thing based on what it's most similar to. It's really that simple. And the name K Nearest Neighbors might sound a little technical, but it's actually not. Let's break it down. The K is just a number you pick. It's how many neighbors you're going to ask for their opinion. Nearest is, well, pretty obvious. It's the data points that are closest. And neighbors are just those surrounding points that get to cast a vote on where the new guy belongs. So we get the concept, but how does this proximity vote actually work under the hood? Let's walk through the actual mechanics of how the KNN algorithm makes its final call. The process is actually beautifully simple. First step, you pick a value for K, the number of neighbors who get a say. Second, the computer calculates the distance from our new point to every single other point. Third, it picks out the K closest ones. And finally, those K neighbors hold a vote. The new point gets assigned to whichever class gets the most votes. Majority rules. I love this quote from our source material because it puts it so perfectly. That K you choose, that's basically the size of your jury. Do you want to ask just one neighbor, or do you want to get the opinions of, say, the 5 closest? The choice of K is totally up to you. Let's make this super concrete. Let's say we pick K equals 3. The algorithm goes out and finds the 3 closest neighbors to our new point. Now, if 2 of those neighbors are from Class A and only 1 is from Class B, well, Class A wins the vote, 2-1. And just like that, our new point is now officially a member of Class A. That's it. You might be wondering, though, how does a computer actually measure closeness? The most popular way is something called Euclidean distance. Now, don't let the fancy name fool you. All it means is the straight line distance between 2 points. You know, like if you took a ruler to a map. It doesn't matter if that map has 2 features or hundreds. The principle is exactly the same. Okay, so this is all really neat in theory, but where does this simple little idea actually pop up in the real world, in your day-to-day life? Honestly, you are going to be surprised at just how common and how powerful this idea of learning from your neighbors really is. Well, what's pretty wild is how much of our daily online life is shaped by this very principle. KNN or ideas like it are behind Amazon's product recommendations. You know, that customers who bought this also bought thing? That's it. It's what suggests your next show on Netflix. It helps decide which ads you see. It's even used in things like face recognition and, incredibly, in medicine for things like classifying cancer cells. So just how valuable is all this? Well, get this. For a company like Amazon, our sources say that over 35% of their revenue, 35% is generated by their recommendation engine. That is a mind-boggling amount of money being driven by algorithms like KNN that are, at their core, just finding your data neighbors to guess what you'll probably like next. And really, that's the main takeaway here. This algorithm, which is based on a super simple, totally human idea of just looking at your neighbors, It's one of the engines that powers the incredibly complex, personalized, and hugely valuable online world that we all live in every single day. So I'll leave you with a final thought to chew on. If all of your personal data, every product you've bought, every movie you've watched, every article you've read, was plotted as a single point on some giant invisible map, who would your nearest neighbors be? And what could their data